Welcome to my ASMR chemistry classroom, and today we're going to be doing another request. Someone asked to talk about isomers, so I thought it would be great to do that with the molecular model kit that I have here. Okay. Alright. So what I'm going to do is build an isomer of pentane, and then we are going to see how the different structures work and still give the same formula. Okay. So this model kit, the way it works is very similar to most molecular model kits, where black is defined as carbon and red is oxygen and nitrogen is blue. And then we've got white for hydrogens. Okay. For this video, we're going to focus just on the carbons, and all the other locations that would have hydrogens, the hydrogens will be implied. So we'll just know that they're there, but we're not going to put them on. So I'm going to start with, as I said, we're going to do pentane. Okay, so pent is the prefix that means 5. So there will be 5 carbons. And this particular isomer that we're going to be making is the long chain isomer of pentane. So that is known as n-pentane. Okay. Every carbon is bonded directly to just one other carbon at most on one side, one other carbon at most on the other side, unless it's at the end. I'm about to put the last carbons on the end of each of these. Okay. Alrighty. So I'm going to move this out of the way so we can see a little bit better. Alright, so here's our pentane. 1, 2, 3, 4, 5 carbons. Each of the carbons at the end, they have 3 hydrogens. 1, 2, 3, each bonded there. And each of the carbons that are in the middle of this molecule, they each have 2. 1, 2. Okay. So ultimately, the formula for this compound you can figure out, and I think I do want to write a little bit, so I'm going to get my little notepad here and get one of my pens. Here's one of my fountain pens. So the chemical formula for alkanes, that is with just single bonds, hydrocarbons, C, N, where N is the number of carbons, and then we have our hydrogens, and the number of hydrogens that you will always have on these alkanes is twice as many carbons that you have, plus 2. And the reason why it's plus 2 is we can see here these end carbons, they have 3. Okay, so it's 2 plus 1 on this end, and 2 plus an extra 1 on that end. So we have this general form of the formula. That means that for pentane, it is C5H, and we would double the 5, so that would be 10, plus 2 is 12. Okay, so there's our formula for pentane. And the way we would draw this structure, if we were writing it using line angle drawings, is it would look like this. Okay, carbon, 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 carbon. We show the bonds one line if it's a single bond, and we do not include hydrogens on line angle drawings. Okay, but what if we have a structural isomer of pentane where there is what we call branching? Okay, so branching is where one of these central carbons, instead of just having 2 other carbons around it, it is bonded to another carbon. So in this case, we now have this carbon is surrounded by 3 other carbons. Okay, it is still pentane in terms of identifying how many carbons there are, but now in terms of naming, now this video, the focus is not on naming, but you can see that there is a butane here, 4 carbons, that has a methane coming off of it. And so we would count these carbons, 1, 2, 3, 4. So this carbon is coming off of the second carbon, this methyl group. So 2-methyl butane. Okay, so the naming aside, I wanted to focus more on this being a structural isomer, but still having the same formula, and then drawing how we would draw this structure with line angle drawings. Okay, so is it still C5H12? Let's look at this. 1, 2, 3, 4, 5. Yes, we still have 5 carbons. What about the hydrogens? 1, 2, 3 for this end carbon. 4, 5, 6 for that end carbon. 7, 8, 9 for that carbon. 10, 11, and 12. Yes, indeed. This is C5H12. And the way we would draw this with our line angle drawings, very similar to how it looks here. Okay. Okay. Now, what if, let's imagine we don't have a model kit handy, and you were trying to think of all of the possible isomers that the pentane could have. And you thought of this one, you drew it out, and you thought of that one and drew it out. And let's say you thought, okay, I'm going to draw another one, and it's going to look like this. Okay? So, at first glance, you might think that you've drawn a new one, but let's take a look. Okay? We just created this molecular model of this isomer here. Okay, and it looks like that, matches pretty well. Okay, but if I were to take this same molecule, I haven't done anything to it, I'm just going to turn it. Okay, if I turned it like this, guess what? It is the same as this one that we drew. So these two are equivalent. Here we did not draw a new isomer, a new unique isomer. This is also 2-methyl butane. Okay, so just keeping that in mind. All right, so here is another possibility for, oh, let me show you something else too. Because these are sp3 hybridized, these are single bonds, that means there's free rotation around these bonds. Okay, these are sigma bonds, so there's electron density between these two carbons, but there's no reason why these can't rotate. These also can rotate. Okay, so that means that it is possible that this methane at some point in time could be up like this and look a little bit different. Okay, so I just want to keep that in mind, that whether you go up, down, you could also have this being pointed down instead. Okay, so now let's create another structural isomer. And what I'm going to do is I'm going to take off this end carbon. And the only place I can put it where it would create a new isomer is if I bonded it to this central carbon here. Okay. So what I've created is a highly branched isomer. Okay. So look at this. We've got this central carbon here, and it is branched every direction. So although this is pentane in a sense, because there are 5 carbons and it's an alkane, in terms of naming, you look at this from the point of view of it being propane, there being 3 carbons, and then in this central carbon, the 2 location, you have 2 methyl groups coming off of it. Okay, so you have 2 dimethyl propane. Okay, but again, highly branched here. So if you're doing line angle drawings of this, it's kind of funny because it just sort of looks like an X, you know. You've got carbons. You could show these being a little bit closer together if you're just trying to show some perspective. Put it like this. So if I were to hold this like this, it looks like we have a tighter bond angle here and a wider one here. In reality, this is perfectly symmetrical, tetrahedral around this central carbon, 109.5 degrees around every single one of these CCC bonds. Okay. And once again, we can prove to ourselves that this has the formula C5H12 because the central carbon has no hydrogens around it. All 4 spots are taken up, being bonded to carbons. And each one of these peripheral carbons, they are at the end of the molecule, and they each have 3 hydrogens. So we've got 3, 6, 9, 12. There are the 12 hydrogens. Okay. So there's a very short, succinct overview of structural isomers with an organic alkane molecule, pentane. All right. Hope you enjoyed this. And by the way, if you are interested in this molecular model kit, this is kind of cool because they... Here's my pen. My pen is like get out of the way, molecule. This company called MegaMolecules. Bring it over here so you can see. They have told me that if anyone wants to order these, they can get 10% off if they use my name, my last name. So if you do want to order them, if you just put Holman in the, I don't know, maybe there's a discount code, I don't know, you get 10% off. So I'm not here to sell these, but I do tell you that because I sometimes use these model kits when I make videos, and fairly often people ask me, what is that model kit? I want to get that model kit. It's pretty small and portable, and I like the style of it. So there are quite a few good ones out there, but I like this one. Alright, I'm going to deconstruct my pentane, and I'm going to thank you all for being here. Really appreciate it. I'm looking to create more videos on organic chemistry, but also I've gotten some requests for more basic fundamental concepts in chemistry. And then I know that I have my general chemistry students and AP chemistry and high school chemistry students who need help with the general chemistry type problems, and so I will always do those as well. So I'll do a mishmash. All those are fun to do, so I really enjoy them. Alright, thank you for being here. It does help me and my channel, and helps my channel grow if you like the videos. If you actually do like them. If you don't like them, then you don't need to like it. But if you do like it, I ask that you like, and also please consider subscribing. That really helps. So, alright, thank you again, and thanks for all the comments. I adore all of you and really enjoy being here. So I will see you next time.